Hi there, welcome back to our, I think, fourth F-Sharp online meetup here tonight here in Germany. It's 8 o'clock, almost 8:30. So I'm very happy that all of you are here again and that so many people are actually attending these online meetups. So sorry for the late start. I just had a total PC crash, Skype crashed, OBS crashed, basically everything crashed. So I tried to do the normal thing and just rebooted my PC and hope that everything will work out fine today. I just updated OBS yesterday, so I hope it won't have some problems now that will have some of these issues again here in this online meetup. So first, before we start, I want to talk very briefly about FSharpConf. So in the last couple of weeks, we announced FSharpConf. We is the other Roman, Thomas Petricek and me. We are organizing FSharpConf this year on the 5th of June. It's a Friday, all-day long conference. It will be free to attend, so everyone can basically attend. There will be a meetup page soon where you can register, but you can just show up to the stream, which will basically be me and Thomas and maybe some other co-hosts streaming for 8 hours or 10 hours during the day, which will be quite a marathon. But I think this will be a pretty cool conference, so the speakers are coming up nicely. We have a couple of them already, and we are trying to find a good mixture of people, of F-sharp stars and some newcomers. We will have some mixture of applied F-sharp, how to actually use it, some machine learning, some domain-driven design, which I'm really into if you know me and my other stuff. We will, or not we, but one of our speakers will show a new programming language for kids, which I'm pretty excited about. So this will, I think, be a pretty cool conference. So would be really happy if you share the love for this conference as well and might attend it. So all the infos are on the F-Sharp online Twitter, and you can go there and just put this into your calendar. Would be awesome if you show up. So today we are going to talk about some advanced functional programming stuff. So the last couple of days, the last couple of times we had this, I don't know who said it the first time. I think it was Matthews, the Monad drinking game, where he said basically every time the word monads gets mentioned, that you got to drink. And because I think the first 3 meetups basically didn't have the word monad at all in there, you needed to just stay sober. So today it might be a bit different because we're talking about all those fancy concepts of monads and applicatives and lenses and whatsoever. I don't know if I will get at least 50% of it. But we have a great speaker here who has promised me that he will have a nice and beginner-friendly introduction into all of those concepts. And yeah, a warm welcome from me to Josef. So hi, Josef. How you doing?
Hi. Great. What about you?
Yeah, great that you're here. Very happy. So how are you doing? Where are you at the moment? In Czech, right? You're living in Czech?
Yes, in Prague.
In Prague directly. Cool. Why are there so many F-sharp developers in Prague or in Czech? It feels like there are so many of them.
No, I don't know. Roman encouraged us to, like with the sharpening, he started it, and now everybody joins.
Okay, he's doing a great job there. That's basically true. Yeah,
definitely.
Totally. But he says yeah. So you gave this talk at this F-sharping meetup as well, and you had like 40 attendees or something.
2 times actually. Once it was a talk, which will be mostly today, and the other time I had a workshop when I showed it practically for 3 hours. So yeah.
Awesome. So we're not going to do 3 hours today, so don't be afraid, people. It's basically a talk, and so what are you going to talk about?
Yeah, I'm gonna talk about a topic that if you play the Monad drinking game, you're gonna get wasted. Absolutely. So Basically, I'll talk about concepts which in F# are put into the reality with a library called FSharpPlus. So I hope some of you already tried it, but if not, you will after today, I hope. But the concepts are pretty general, like they apply to every language. So actually at work, I write C#, but like knowing this stuff, I also apply them in C#. So
Cool.
it's applicable everywhere. I would say even especially C#, since like most of the jobs are not F# yet.
Yes.
But yeah.
Yeah, really cool. So you will talk about an hour, I think. That's the time frame we have. That's
Yes,
pretty okay. Like okay, and we have like at the moment we are 126 attendees, 29. So this is pretty awesome.
Nice.
Yeah, really nice that so many people are there. And I was just basically part-time reading the chat here, and people are saying they're loving the meetup and they want to support, and I'm really happy about this. So that's some good motivation to keep going and organizing all this, because it's quite a lot of work, to be honest, with 2 small kids at home. And I'm pretty happy that they're sleeping now, because I just told you, Joseph, in the pre-talk, we had basically a total meltdown day today. It was like... anyway, so that's why I'm a bit stressed maybe today. So I'd say if you have any questions in the chat, just put them down here, and as we did the last times, I will note them down, maybe organize them a bit, and there will be some natural points where Joseph will basically ask for questions, and I will give them here. So I'd say... you share your screen, and then we'll start.
Let's do it.
Oh, and if there are any technical problems, and I don't know, maybe some sound is gone or something, just write it down in the chat. I might forget to unmute myself. Happened a couple of times already. So yeah, just ping me, and I will try to sort this out. And if we're gone, my computer crashed again. So then just wait, we will come back. All right. Did you share? Did you share?
Yeah.
Okay.
Yeah. Can you see the screen?
Wait, I didn't. Yes. Here we have the screen. And yeah, as you can see, I didn't try to pronounce his name. He told me, but I can't really say it. So I don't want to embarrass myself. So yeah, I will mute myself now. And I wish you all a lot of fun and a lot of knowledge and a lot of brain meltdown with Joseph.
Okay, thanks. So I guess let's start. So first, let me introduce myself. I have a weird name. I'm called Josef Starýchfojtů. I'm from Czech. Quickly who I am, I'm a head of backend at Muse in Prague, but basically I'm just another guy with GitHub and Twitter. So yeah, that's it. Let's start. Questions? Or are we done like after this slide? Well, so as you know, this is the famous line, like creator of all memes and everything, and I'm gonna talk about it today. So like this monad thing and all these advanced concepts are usually put into perspective, which says that like it's super hard. People usually don't use it, or they use it, they just don't know they are using it. But today I'm really gonna try to put it in another perspective. I'll try to demystify all this stuff, and I hope you will use those concepts tomorrow in your day-to-day F# project, because I do. It's really practical. So as I said previously, I gave this talk alongside with a workshop, and the code from the workshop is public. It's on my GitHub. It's called Workshop. I will put the links in the presentation also, so you can go there and really see. It's like a whole application. It's an API with the domain layer, the use case layer, and then the API layer, which uses these concepts. So you can really have a reference point after the talk is done, and like play with it more and see some, let's say, more than a basic use cases. So let's start. Firstly, we need to talk how to actually achieve such stuff in F#. So as you may know, there is this inline keyword in F#, which will help us to simulate something like type classes. So basically, if you have a function which says like a plus b, those two arguments, and you put the inline keyword there, then it can work on multiple types, like all types that have this member plus. So we can actually kind of achieve higher order abstraction without it being basically built into core CLR itself. So yeah, we need this, and let's get into it. So first thing we will introduce is something called functor. This time it's not really practical, but it will be used throughout the talk. So the functor is basically like a building block for our future, and it's even the first word mentioned in the famous line. So let's get to it. So the thing is, it's really not that hard, right? Since we use it in programming, it cannot be really that hard. It's not, even though it's like from math, we use it in programming, so we can really see it in the code, which is something we as programmers understand more. So you all know the option type, right? It's basically simulating a nullable type with the coproduct. I'm sorry, I'm going to be using the word coproduct a lot for something most of the people call discriminated union. So yeah, it's a coproduct of some and none. And then you have this option, and you want to write like a function which adds 5 to the option, and then another function which adds 10 to the function, and you have this like duplicated code, right? So as a programmer, what do? You just extract the code. You write a function which has the same parts like in the same place. You call it a map because you want to. It takes a function and the option, and it matches the option and applies the function to the value inside. And if the option is none, it will just continue. And then we can basically like now apply any function to the value inside the option if it's there. So the 5 can be written as option.map plus 5, and there you go. With the result, which is very similar to option, it just has the error in the case. You have the same problem, right? If you want to write these two functions, you have some duplicate code. You have to match all over again. Let's do the same thing again. And we end up with the same function, and let's call it the same way. We'll call it map. Well, I guess now you know even what functor is. It's the thing that has map function. So it's basically everything that we can abstract into this function that you can imagine some like common perception of this is that you have a box, and the box holds value, and the map lets you apply the function to the value in the box. So actually, the FSharpPlus library has a function called map, of course, but the special thing is that it works for every functor. So what the map does is it requires to have this statically resolved type member called map, and it works with any functor. So now we can write a function which is called general add 5, which takes any functor, and it maps with a plus 5 function. And now you can apply it to the option, you can apply it to the result, you can apply it to the everything. And there is also this weird operator, like functional programmers really like these, like they don't want to write just letters, they also need to use the whole keyboard with the special characters. So we have this infix operator for map. This is basically just an alias, which gets used a lot with applicatives, which we will see later in the talk. So yeah, this is not really like useful on its own. We just abstracted a really small sample of the code, but we will need it later. So let's get practical. And the first task we are gonna solve is how to properly and easily do validation in the code. The answer to this question is don't. Parse instead, right? There is this line, don't validate, parse everything. So you don't really want to have the same types in your domain layer and in the let's say API layer as parameters. You want to really restrict the types to handle to be like just valid, represent just a valid state. So let's say you have this recipe object, a record which has a name with a non-empty string, person count with a natural number, ingredients as ingredient non-empty list, where the non-empty list is also typed from the FSharpPlus library. Other ones are just like created in the code somewhere else. And then you have the parameters. Like the parameters are something you deserialize the JSON that comes from the API to that has just the simple types. It has strings, it has integer, it has lists. But now you are given like a simple task in the API layer that you get these parameters, but you need to parse them to the recipe. And how would you do that? Like, just think of a moment, you probably already have done that. The way you usually do that in C#, for example, is that they have like a list of all the errors. They try to parse every member of the record. And if they succeed, they save it somehow. If not, they will add an error to the list. And at the end of the method or something, they check if the list is empty. If yes, they try to create the record. If not, they will return the list of all errors. The crucial thing here is that we don't want to return just the first error, right? We want to return all the errors, because if you have ever filled out some form, you don't want to be notified like with the first mistake, then you submit again, then the second mistake, then you submit again, and so on and on. You want like the full list of all errors in your parameters. So yeah, the other way, like it's pretty clumsy to write it somehow. So let me introduce something which will greatly help us in this situation to solve this problem, and it's called applicative. So let me introduce it actually very similar to how I introduced the functor. And that, let's say you have now, again, like options, and you have two of those. You have two options of some number, and you want to add them. So you basically match on the first option. If there is something, you match on the other one. If they both have the value, you return a new option with a plus b. And in all the other cases, you basically return none. Then you want to like do a product of them. You want to multiply the numbers in there. So you basically need to do the same thing, right? Which is annoying, and like it has the same problem as we had previously. It's just a bit different. So as a programmers, what we do, we want to extract the code so we don't have to repeat ourselves, right? So let's do that. And actually, the function that we extracted is defined in a pretty different way than I showed you on the previous slide. It's a function which takes an option of a function and its argument and returns the result, right? So it's implemented pretty easily. So if it matches the function option, if there is a function, it matches the argument option, and if they are both there, you'll just call it. So the way you can see it is basically it's called apply, because if you would remove the options, it's basically just a function application. You apply the argument a to the function f you give. It's just in the like world of options. It's wrapped into the boxes. So we need to just tell it how to unwrap it. And like this function is also used a lot more with the operator, with this one right over here. And there is also another thing that we need to have in order to call this applicative, and that's the return function, which is basically just a way, if you have a value, how to elevate it, how to like put it in the box. So for the option, it's just a sum constructor, right? If you have a value, you just put the sum there and you have the option of that value. And like the lines 14 and 15 then show the use case, like the usage, right? If you have you first use the result. The result is the general function for the return. So it's basically sum there, also just using the return. So you create the option of a plus function, then you apply 5 to it, and then you apply 5 to it again, and you get sum of 10. So it's really just calling a function, but you have to put the weird things there in between to make it work in the like with options. But if it wouldn't be option, you could just call it like that, and it would work. So this basically elevates the stuff to the world of all applicatives, basically, but in this case, the option. And the line, the last line shows how to write it. Let's say this is how it's usually written. You basically don't have to like put the sum there. You use the infix operator for map. So it's a bit different, but it acts the same. So basically it's just a way how to apply functions in this world. And let's see how like it can help us. Let's get back to our problem. We will introduce, well, actually not we, but FSharpPlus library introduces something which is called validation. So even though I said like don't validate parts, the type we will use is called validation, and it's very similar to result, right? So you have the failure scenario of some error, and you have the success of something, of anything. We will define all the functions on it we need. So the map function is defined the same way like as an option or as a result. That's easy. But the interesting part is the apply function here. What it does is that, like on the last line, if both validations are success, like if the function validation and the argument validation are success, it will create a new success and it will apply the value to the function. That's okay. But in the other cases, it does not throw the error away. So if one of them is failure, it will keep it error. And the nicest thing about this is if there are like both failures, it will add them together. This plus function means that the type can be anything which can be concatenated. So it's usually like array, right? So you will have an array of errors, and it will concatenate those arrays or like lists or something. But theoretically, it works with strings, which concatenate the strings, or even like numbers. You would add numbers, but that's not really practical. So it's really just arrays or lists of errors. And as you can see, that for each argument that will fail to apply to this function, it will accumulate the errors and give them to us at the end, which is really what we want with the problem we mentioned in the API, right? So let's see how we can use it.
I want to just interrupt you for some second.
Yeah.
2 things. Can you go one back, please? So there was one request from the audience that you might, if it would be great if you could use your mouse a bit more to show where you actually are. Might be easier for some people to follow. Like if you're talking about the map and the apply and so on. And I just, sorry, but here, if is this a mistake or am I stupid? This success FA. So where does the F and the A come from? We have unpacked VA and VF.
Oh, sorry, that's a
it's a mistake, right? So
here it should be F and here it should be F and here it should be A.
Okay.
And here it should be VF and VA. Sorry. Thanks for pointing that out.
Okay, keep going.
Okay. So let's really see how we can use it in the API to solve our problem. So we will define the error. So like the error can be that the name is empty, the person count is negative, and the ingredients are empty. And this is really something I really like about this type of programming, which I really try to do even C#, is that when somebody asks me what can go wrong with my code, I don't have to really dig into the code. I'll just tell him, look at this type. This type states all the possible things that can go wrong. And if you handle them all, you are good to go. So it's a nice documentation also. And then we can create these like sub-functions like parse name, parse person count, and parse ingredients, where we everywhere use some function which creates the type. So for example, non-empty string.create is something which takes a string and returns an option of non-empty string, the same for natural number, right? It takes the integer and returns an option of natural number because like it states that it can fail. And then on validation, there is this function called of_option, which will basically match the option. And if it's sum, it will create the success of the validation with the same value. And if it's failure, it will put this error right here stated in the if it's none, it will put this error in the failure case. So then we have these sub functions, which each handling like the single property, and we can finally really compose these together with the apply functions and call the whole recipe.create method, for example. So how we can really read it is that you call a function recipe.create with params.name, params.person_count, and params.ingredients, and you just have to put these operators there to handle the errors, like the accumulation of errors and everything, and it will work. So the return type of the whole thing is now validation of recipe and error list. And then if you call this function with, let's say, all parameters invalid, so there is like an empty string, negative number, and an empty array, empty list, sorry, then you get a failure of all the errors there, which is pretty nice. And also something to state about this is that you will basically develop your own like a mini parsing library for this validation with this function, which you will use in the case. So it's actually, you can, for example, I could parameterize this function parse name with the error and call it just parse non-empty string and use it in the call case, so I don't have to write too much code. So yeah, I think this is like one of the and what we achieved like with the applicative is that there is no boilerplate. We don't have like the mutable list with errors. We don't have like all this shenanigan around. And also one even stronger point is that we don't have a duplicate logic, right? So what you usually see is that if the business layer checks for some condition, let's say that the a is less than 5, you will also write this code when parsing or validating the input, and you just duplicated the logic into places. But with this, it really keeps the logic only in the function, and it will tell you right away if it's wrong or not. So if you change it, you can change it on just one place. And as I said, there is if you go to this repository in the file API FS, you can really see some real scenario, how I parse some request. It will also show you how to, for example, deal with lists if you want to like return an error for each item in the list or something like that. And also it demos like the small parsing library, let's say, you can use, but it's really just a reference point for you. And I made a typo valuation. Nice. Okay, so I guess this is the first kind of a natural breakpoint where if there are any questions, it would be good idea to answer them. So are there any questions?
There are a couple of discussions which are, I guess, basically coming up a lot when you're talking about those things, which is basically the use of operators. So a lot of people don't like custom operators, and so there is basically the discussion if this is a good thing, if this is not a good thing, how we should actually need to talk about them, or are they useful or not, or
okay. So yeah, this is a pretty like, let's say, opinionated thing. I've seen many discussions around that, and one I really liked is basically if you made custom operator, then it's usually not good. If you make your own operator, it's kind of weird. But there are not many, let's say, standard operator. But I don't really see the harm of using the standard operator because, for the first time, this code is super cryptic. If you show it to anybody, like a standard programmer who does not know F# or anything like Haskell and stuff like that, he won't really understand what are these operators and what it is. But for a programmer who knows what they are, and there is not many of them, basically I think like 4 or 5 are used a lot, and you already have seen 2, then it's okay. It really saves the what you really want to have in the code is as most business logic as possible, as less noise as possible. And if I would state here like apply every time, it creates a noise a bit. So those operators help to reduce the noise in the code. But it's up to everybody, of course, to choose it. It's not something I would say that's like super dramatic or hard to change in a code base.
Okay, so my take, or I'll wait. I go to the to us. So what else do we have here about this? So it's again, it's this newbie thing. I think so. So if you're basically, I think it's a question where to optimize for. So if you're optimizing for beginners to read your code base, it might be very hard for them to actually see this. But if you optimize maybe for reading within your team, and you have those, I don't know, 3-4 operators that you're actually using, it might be a good thing. I like this term that I've heard for using those result or apply and map operators and later bind, like overloaded white space. So, which is basically so if you're using them, you might get just used to overreading them. So because it's basically just function application for some special cases. In this case, I like this notion of overloading a white space, especially if you have this thing here in your let's go here in the recipe create, and it's basically and you use those 3 functions as basically as you would normally if you wouldn't have this validation logic. But I think you need to make sure in your team how you can actually work with those, if it makes sense or not. And Paul, just go.
Yeah,
go for it.
So one point maybe, like even with the operators, it comes to the bigger topic. Like what about the team? if you have many people in the team, what to do about it? So I'll say that like in our case in Muse, we are actually like a proof that it can work even for people that are pretty junior. So I had people that joined the company and they did not even know how IEnumerable works properly. And like 2 weeks ago, the same guy came to me and he said like, Pepa, I really need you to push on like the link queue and the monad things in C#. I really need them. My code sucks without them. So like I see great adoption of it. Like of course, there are many talks about how to make the functional programming and like generally concepts that are not applicable to whole industry success in your work environment. But one of the key points is actually someone who really cares, who is there for answering questions, making the presentations. So I'm happy that in Muse it's not just me. There are actually more people, and just this who write F# and we try to make a lot of stuff work in C#. But if you push long enough and you really show the benefits, which are undeniable, I think you can make it work with like any team. I don't think anybody is like naturally stupid or something. Everybody, it's just the amount of time you spend learning it. So yeah.
Yeah, I can relate to this, and also, but what I can also relate to is what Paul said. Paul Bazucci was remember the underlying theory can or is surfaced in a lot of different ways. Here we just happened to be seeing in a particular style, basically the world according to GHC, so to Haskell, basically. So this the ideas are coming from Haskell, of course, or not of course, but that's where they are born, and also this operator thing, I'd say, and we're using them here. And in my opinion, if you're not going crazy with those operators and you have those, especially for apply and for map and for those things, they make a lot of sense, especially for those types or for those examples that you have shown yet. So, yeah, I'd say that's about this. I think you can have a pretty religious discussion or fight or war about those topics. Let me see if there is anything else. So there was the question, how is this different to fstoolkit.error handling? So there's also Jimmy Bird here, which is pretty cool, who is one of them, who is the maintainer of this library. You know this library?
Sorry, I don't know this library.
Okay, so but he's basically saying it's a big overlap, but they are basically concentrating on the error handling part, so the validation part and all this stuff you were just mentioning, and not on the other things that you're going to talk about anyway soon, and but that are in FSharpPlus, right? So I think this is then basically the difference, then that FSharpPlus is much bigger thing, and the one of Jimmy is basically concentrating on the error handling stuff. So is there anything else? One sec. Yeah, there is one question: how to avoid validation logic duplication in F# backend and JS frontend. Use Fable. I mean, I'd say I'd say this would be the natural answer, right? Use Fable for this. If you have anything else to add there, I mean, that's what Fable is for.
Well,
and
you can either use the same language on the server and the client, then you have, for example, Fable. If you use the F# server, or you have to develop a framework of serializing and deserializing, like the logic, basically, which you basically invent your own language in some extent.
Yeah.
So it's a and you can even just duplicate the logic, right?
Yeah.
if the application is not that big and
Yeah.
it's just not worth it, you can just duplicate the logic and live with it. Maybe have like a wrong sleep, but
yeah. And I'd say you might have different. You might even have different validation logic in the front end, because you have some nicer user experience that gives some hints here and there, and then you have your domain or your behavior where you have your hard constraints that are a bit different maybe from the front end. But if you want to have the same thing, I'd say that's what is a perfect match for Fable. So
I was actually thinking about this topic lately, and there is another option I see, that you could basically make the front end learn the validation logic based on the responses from the server, which is a bit dangerous. I guess I haven't tried it actually, but you could, if you have a pretty nice error handling on the server, for example with this, you could basically recognize for which input what was the output, and then just not call the server again in the next case. But
it might be a efficient idea. Have never thought about this, to be honest. But nice. Okay, so shall we go on?
I guess so.
Cool.
If this is covered, so,
yes. So
let's keep going.
I will switch back to your screen, and you have the mic again.
Great. So let's continue. Now it's the part where it gets a bit scary, but still practical. And now if you are playing the drinking game, I'm giving you 5 minutes or something, then you will just fade out. So yeah. So I'll actually introduce it in the same way I introduced the previous concept, of course. So let's say you have these three functions, the square root, logarithm, and divide. And you have a function where you want to do everything. So normally this is pretty easy. The nice thing about this function is that you can really see what it does. You just compose the stuff with the pipe operator. yeah, that's it. But what's wrong here, right? Those functions are not total. We don't want them to blow up for the bad inputs. We want to handle that. So let's handle that, for example, with an option. So if you rewrite those functions to handle the bad case, now you make them total. That means they don't blow up. They always return something. But now the function got really messy. Now the noise is all over the place because we need to match and everything, and the logic what we wanted to express with the code is away. We want to return this notion to the code, and like the matches, we have seen something similar with map. Well, we could try using a map, right? But then something bad happens. Well, each of those functions return an option. So if you map the first one, you get an option of an option, and then you need to map again and again. Yeah. So now you are stuck with option of option of option of option, recursion of options, and what to do with that? Well, you could match it again basically at the end, but that's not what we wanted. So what if we could actually introduce a function to solve this? We'll call it join, which takes option of an option and unwraps it to just an option. And basically, if you have the map and the join, you have the monad. So yeah, this is what a monad is called when you have a map and join. So then you can define these other functions, because like there is several ways how to introduce the monad, how to use it. So the map and join is the first definition. The other point of view is this bind function. This is called bind. There is another weird operator, I know. It's called bind, and it takes the option, a function from the inside of the option to some other option, and it will return just that option. And you can simply implement it with just the tools we have shown. You can implement it with map and join, because you basically map it, you get an option of option, and then you unwrap the option. And the other possibility is to define this. It's called Kleisel arrow. It's basically you just have the not straight like A straight away, but you have two functions from A to option of B, from B to option of C, and it composes them to A to option of C, which can be done like pretty simply with the bind operator, for example. Now I will diverse a bit before going to more practical. Now I would like to actually demystify the meme for you and explain the sentence that the monad is just a monolithic category of n functors. So we have seen it's a functor, right? Because it has the map. And in programming languages, almost, I'm not sure entirely, but basically every functor is end functor. So then you basically say that monad is an end functor. And if you give this join thing, it makes it a monoid. So it's just a monoid in the category of end functors. I'm just kidding. But yeah, so I like this expression of map and join, like that the monad is map and join, but these other two are used in practicals as well. But now let's talk why they are so important to programming, right? So let's look at let's compare those like functions. Let's say we have an unsafe square root and an unsafe logarithm, and then we have the safe option for them, like square root and logarithm. If you want to compose these with the unsafe, you just use the compose operator with like classical F#, which like puts the functions together. And now we can use the Kleisel arrow for that for the overloaded ones. So the difference between the code which handles errors and does not handle error is just this small equal sign. That's it. Like the code is basically the same thing. So what we actually did, we extended the function composition. So the way how I view monads the most in programming, and how most of the people come to this like resolution with monads that they now understand it, is this way. It's basically a way how to say to the to your program what to do more in the composition. That you are like, yeah, you have the normal composition, but I need something more, but I don't want to deal like with it everywhere. I need it like encapsulated in one place and do it all over the place. And the fact that it's really just an extension of function composition in your whole code base is even seen on this monad computation expression, otherwise known as do notation, or in C# as LINQ. So if you look at the unsafe code, not written with like the composition pipes and everything, but more with let's say more imperative style where you have more variables and stuff like that, and you look at the safe version with the monad computation expression, you may know like an option computation expression or result computation expressions and stuff like that. So monad, that's a computation expression from the FSharpPlus library, which works with any monad. And you can see these parts of code, they are totally the same. The only thing that's different is the bang here, the return here, and the thing here and here to make it like work. So it's really the same thing. It just allows you here to do something more than just take the value and put it there. It will take the value and put it forward, but it will also do something else. So in case of options, it will handle like the errors in a way that if the sum of it's none, it will be none forever, and the code is not executed forward. So yeah, let's see other cases for that. So result, that's also a monad used for error handling. That's been mainly made popular by Scott with the rail-oriented programming. So this will be easy to explain because you all know it. So you basically use it for error handling instead of exceptions. You define the error again, like the same thing as we did with the validation. Then let's say we have two functions, like one create account, which takes an email and password and returns an account. And then we have something that verify account that exists. It takes an account, returns account right away. Both can somehow fail. So again, this function like returns the same thing. It returns the account, the same thing that the other one takes. So if they would not be like extended with the result there, we could just compose them. But we have the result there, so we want to tell our program, okay, in the background, do like the rail-oriented programming, do the error handling for us. We don't want to see it here. We just want to like take care, state what we want to do, so it's like readable and everything, easy to change, and do the nasty stuff for us in the background. We will deal with the errors when we want to, which is usually in the top layer. And on the previous slide here, we have used the Kleisli arrow for instead of this function composition operator. So the bind function is basically like a pipe, right? Because here I call the create account with email and password, so I get a result of account and sign up error. Normally, without the result, I would have only the account, and I pipe it to the next function. So this is really just a pipe. And this is also something maybe on the topic of the operators. Like we use a pipe a lot, right? We use the function composition. So we just need the pipe again. It's the same pipe. It's just expressed differently because it can do more than just the function composition. It can do the extended function composition. And again, really, if you want to or if you need to, which you really probably need in some more advanced use cases, you can just always, you don't have to write with these compositions and pipes and function composition. You can really always just fall back to the normal code with the monad computation expression. If you need to do something more, you find it like more readable. And that's super great. Like the monad computation expression is nice because what's usually the case if the flow is not so simple, if you try to use a lot of binds and compositions and stuff like that, Then if you change one function's return type from normal one to, let's say, also result one, you need to change a lot of code here. But with the computation expressions, you just add the bang here and you are good, or remove it. So it's really easy to change the code accordingly. So yeah, that's another case. Like instead of which you can use Monads is the extended error handling, like the composition with error handling in the background. Now to some less known monad, which will actually help us solve something which every developer who comes into the F# asks on Stack Overflow, like everywhere from the OOP world. How do I do dependency injection? Well, let me show you. The thing with dependency injection in like the classic OOP world is that they basically split the inputs of a single function to two. The first one, those are the dependencies. They are passed via some constructor to the class, to the service, usually called. And then the other type of inputs are given to the function itself. So if we are speaking like the single responsibility principle, you basically your service should have just one function. So then the whole class is basically a single function which takes two kind of inputs. You can think of it as like carried by a group of inputs, and they have nicely separated. So in the what's nice about this is that if you usually change these dependencies, you don't want to change all the like usages and pass the dependencies through the whole code, because if you have it like this in F#, let's say you oh, sorry, the monad should not be here. This is just normal code. So, but you have the like get user function, which takes the repository and the email and calls get by email on the repository. Then you have the add shopping list, which also takes some another repository like shopping list repository, and it calls repo.add for the shopping list. And in the usage, I messed up. Like I should not have copied the code. The monad should not be here. Also the banks. This should be just normal F# code. But what I want to express here is that to the main function, you have to not just pass the email for which you want to do the action. You have to also pass the user repository. You have to pass the shopping list repository. You have to pass it everywhere, like here and here. And the codes get really messy. And when you change it, you have to change like the whole code base. Like if I would change the user repository, that it needs also some other repository, HTTP client or data provider or whatever, I would need to change the whole tree of like all the usages and everything. That's horrible. So what the reader will do, the reader will keep us on the function level. It will not force us to introduce the classes and everything, but it will basically just separate those inputs into the two groups the same way it does in object-oriented programming. And what a reader is just a function. So if I have this type called reader of RNT, by the way, this is also in the FSharpPlus library already included. It's just a name for a function. So you can really see it takes two type parameters, and it's a function from R to T. This R is usually called environment. So the reader basically says, for this given environment, I can give you this. And then we need to, of course, define all these stuff we have defined for the previous types. So the map function is just a function composition, right? The other stuff, it's basically also just a function composition, just a bit complicated, but it's super easy if you think about it. I'm not sure it's like crucial that you get it right here. You can just look at it later, but we can define all of these, and then what we can do is that we rewrite these atomic functions, as I call them, that use the reader natively. They really need it. So for example, here, I say that the get user takes an email, and what it returns is a reader of which is another function. So you can really, the reader cannot even be, does not have to be here. It has to be there for us to use like the extended function composition, but like the semantics are the same even without the keyword. So getUser takes an email and returns a function called reader, which takes the iUser repository and returns the user. So then the signature is like this. We have from email to a reader of the environment and a user, where the environment somehow implements iUser repository. So we have really split like the input to two parts. We have split it to the email and then the environment here. And if we extend the environment here, it will just put another constraint on the type. The same thing we did here for adding the shop link list. So the shop link list takes a shop link list, it takes another environment, and then you just add it. So you have this function which you can call, it will give you the reader at the end. But now the crucial part is the composition. So here we want to get the user by the email. We want to create an empty shopping list for it and add it to the database. And you can see nowhere here are we passing any repositories or anything. That's what the extended function composition does for us now with the reader. So your code is nice and clean. If you change the environment, you don't have to go anywhere, just here. And what's really nice about this, as you can see, the whole return type of this function is, if you give it to email, it will give you a reader of the environment, which can give you the shopping list, where the environment inherits both the iUser repository and the iShopping list repository. So with these type constraints, it composes to like more constraint type, but we don't have to really say that explicitly somewhere, which is great because it really encourages the minimal requirements for the functions. Well, how many times have you given a function more than it needs just because it's convenient? This makes it convenient to give it as like least as it needs, which is super nice. And only at the top, like in your API or whenever, when you want to execute the reader, you will give it the environment. You will basically apply the last function with the environment. Yeah, so that's I think really needed for any functional written application which is like bigger. And I think like not knowing this might also cause the lack of such applications. So this is really like this is the deal breaker for me, like how to solve the dependency injection in like a purely functional way. So this is how it's tackled. One last monad for you. It's writer. That's a monad which is not used a lot, let's say, but I included for one particular reason, and that's because we use it in C#. We have even several use cases for it. So this is a monad you don't really use throughout the whole application as reader or option or result. This is something you just use for specific cases, and it solves the other problem of the reader. So reader says that we take the normal input and some additional input, and we want to hide that one. And for the writer, it states that if we have a function which returns the normal output and some additional output, it will hide the composition of the additional output. So what you might be thinking of is logging, right? Like the function has two types of output. One is the normal one, and one is the output. Let's say it's an array of string, right? So if you have this function create ingredient, it will create an ingredient. Alongside it, it will produce a log. You can see, again, as reader is just a function, writer is just a tuple. So if the writer would not be here, I would be returning a tuple, and that's what writer is. Then you create the user. You create the user with the ingredient. You say user created. And then you can just compose it, or again use the monad computational expression or whatever, and it will concatenate those output from the functions for you. So then, if you run the writer, you basically get not just the user with his favorite ingredient, you will also get the output concatenated, which is pretty nice. So you wouldn't actually use it for logging, right? I wouldn't go with the side effects too far. So basically, logging is not really a side effect in a way. So that's something I would do normally in the function. But you may have some other, like let's say more business logging. So for example, in Muse we have a like a domain where everything can return a notification, right? Every function can somehow alongside it create a notifications for the user, and that would be, and like the way how it was written before is that like in every use case you would create a list of the notifications, call all those like sub functions, concatenate their messages like notifications, and then create a new result with everything in there. But this will allow us to don't handle notifications on the level of like when you are composing the functions, not on the atomic level when you are actually creating the notification. So this is just a nice to know. You can apply it to some domain, not just like let's say or just one module or one domain, not really the whole application per se. And there are other monads, async and task. Those are monads. Actually, when I said that when we are doing join, we unwrap the thing inside there, the task has a function called unwrap on it, which is join. IEnumerable or the sec, also a monad. Basically, everything is a monad. So yeah, and a lot of other stuff, but those are like the main ones. You know these ones, and I guess now it's the second time where we can discuss things and answer questions.
So, okay, let me go through the questions and remarks and comments. Yeah, one last thing to the validation thing. When we said Fable, it was again Paul who said, yeah, the sand trap for shared validation, JavaScript and the CLI use different regex engines, which is yeah, might be a bit problematic then if you have those things then, but on the other hand, who said it? Brandon said, if you solve a problem with regex, you then have two problems anyhow. So might be true about this. So a couple of more questions. So also I had the question, so this monad computation expression, it is also using those static type constraints? So
yes.
Okay, so it has basically everything in there. You just put the monad computation expression in there, yeah, in your set, and you can use whatever you have just showed us.
So yeah, the monad computation expression is basically like the general one which you can use for everything, and it's similar to what LinkU is in C#, where the compiler looks for any implementation of the select method or any implementation of the select many methods. Yeah. This resolves like the implementation of these corresponding methods in F#.
Yeah. That's pretty cool. Okay. So another question is, how would you test this monad computation expression? So I guess the question is more, how would you test the domain logic within those monad computation expressions? So would you so if I think he was asking this question when you were talking about the reader monad. So and there he was, the question is basically, would you then implement dummy interface, or would you have dummy implementations for all those interfaces that you're actually using, and which then might be those F# object expressions that you can use for those that are pretty nice, or what do you say?
Yeah, of course. So the only thing you abstract is the environment. That's why I have the interfaces here. And then you basically have like a production environment, which has the real connection to the database, real HTTP client, real datetime provider, real random C generator, and stuff like that. All the stuff that causes non-determinism and side effects and everything. And for your tests, you have like a fake environment or a static environment, which is just an in-memory environment with just a static time. just a static seed for random numbers and everything, and you can test it. So it's actually pretty great that you can test it super easily, because your whole business layer is not dependent on any like concrete or specific infrastructure or anything like that. You have just the reader, and as long as you give it, it's still a pure function. It's really one might tend to feel like think about this more complicated, but it's really just a function that returns a function, and it's still a pure function. There is no side effect going on, so you can really just put the first input there, the fake environment there, and test what it produces.
Okay. Yeah, it makes total sense.
So you can even see that in my second repository, like the one with the recommendations engine for recipes, I have tests there for the whole, even API. Like I test the API in a way that I provided with the API input and give me the API output, and I assert that with the fake environment. So it's almost like an unit test of the whole application.
Okay, and do you see any problems with there was also the question, how does async combine with the read monad? Do you see any problems there?
That's the biggest problem, but it's solvable. It's not something, unfortunately, we have time here for. It's something that's partially solved within the workshop code I have on GitHub. I spoke about it there. For those who know Scala, there is a library called Zio.
I was going to ask you about those. Yes,
that's the solution.
Okay,
that's the solution. Monad composition is very hard, but the FSharpPlus library does handle that. The monads are usually composed with something which is called monad transformer, and that means that the monad knows how to compose with the inner thing if it knows it's also a monad. And you have this T suffix on everything. So if you put the reader T instead, you can use the bind function directly. So you have like two layers of monads, and it will directly go to the, like it will skip the level of the monad, go in there, and you again like return the two stacked monads. It will give you that. But using the raw monad monad transformations, like proved to not to be so practically going well, and maybe also performant.
Yeah.
So that's what the Zio library in the Scala, for example, solves. That it basically says, okay, what you really need. You basically need a reader for dependency injection. You need a result for error handling, and you need an async to make it asynchronous, and that's it. So you create a new type which has three types parameters: environment, success, and error. And you say, for the given environment, I can either fail with this error or return success with this. And you call this in Scala, it's Zio. There was even an attempt from Anthony Lloyd on implementing it for F#.
Yeah, but he had to withdraw it, right? He even withdrew all the code he wrote, actually.
Yeah, he canceled it. When I wrote him on the comment on the blog post if I should start writing it from the scratch for my own usage, or if he's going to publish it, he responded that he's not going to open it publicly, that it's a proprietary project. So yes, we are stuck with nothing, but I hope I will one day we will make it. That's my on my bucket list.
Yeah, this would be really cool to have something like this in F#, because what I have seen, it was basically this reader thing with all the nice things like with async and result, what you have just said, and I think it gives you some really nice features where you have just this environment and can basically swap things out without having all these monad transformers and other kind of effect libraries that are really hard to grasp, but also sometimes a bit strange to work with, I guess.
Yeah, definitely. But actually, I did implement it on my own a bit in both of the projects, both in the workshop, in the recommendation system, to just get rid of the composition. And I used the transformers there to implement it, and it was like few lines of code. So you can make it work easily, but to have all the features that the ZO has and the nice usability and everything, that's also something which is much more time demanding to create.
Yeah, definitely, especially for one person. I guess they are putting a lot of effort into this, and a lot of people are actually also like money-wise involved in this, and this is I think a really nice thing. So what else do we have there? Let me see.
I was actually even inclined to try Scala just because of the library.
Yeah, I can imagine. I haven't really tried it, but it looks really good. So Jimmy also asked, I wonder how the Monads CE is going to handle AndBang. So AndBang, for people that don't know, is coming now in F#5, and it's basically the let. So it's in the computation expression, we have the bind for the let bang. And so this AndBang is basically the applicative that Josef was talking about, right?
Yes.
And is this also implemented in or usable with FSharpPlus?
To be honest, I'm not sure, because that's pretty new, right? The AND keyword. And if you have a monad, I don't really think you need it. It's like, for example, the validation I've showed, it's not a monad. Well, you can make it a monad, but its semantic is that it collects the error.
Yes.
But the bind of monad would not collect the errors.
Yes.
So that's why the validation is not a monad. It's just an applicative. Mm-hmm. And that's why where you would want to have the syntax sugar for it, when you don't have the monad syntax sugar, then you have the AND keyword for it.
Yes.
And I guess not sure it's already implemented in the library, or if it will be, or I'm not sure what's the state.
Okay.
Sorry.
No worries. Let me see. There's one question that I really don't understand, so I just give it to you. Is it possible to write MTL-style monad type classes? I don't know what that means.
I'm not sure about the shortcut MTL.
So let's just leave it there and
maybe like what you can do, you can definitely create your own monads.
Mm-hmm.
And like the way how type classes are hacked in F# is via the statically resolved members, right? So with that, you basically have type classes in a weird way, of course, but you have. And the bad thing about this is that, and here I'm not sure about the all the internals of F# compiler, but you have the type extensions, and when you have this construct in F# like type, option, weight, and you define the members, if it's within a single file as the type, then it gets compiled like within the type, and you can use it with the statically resolved members. But if you define it like in another assembly, let's say, or another file, it does not work. But I think there is some proposal, something to make it work. I'm not sure here, but you cannot really make a type which lies somewhere else a monad from you. Mm-hmm. So now the question arises how they did it like in the FSharpPlus library. Well, in the FSharpPlus library, they were the ones implementing the FSharpPlus library. So they actually define all the functions for the standard stuff, like for options and async and everything. And then there is this pretty advanced statically resolved shenanigan that it resolves that either the implementation lies within the type, which has the standard implementation, or the type has it.
Okay.
So you could implement your own this piece of F# library in your own code base, where you would extend it basically, and you would have a new bind and everything. But I don't think you really need it, because the standard things are there. And
wait a second, Joseph. I think either my sound is really bad now or yours. So in the chat, people can you just tell me if you can't understand Joseph at the moment? Some people in the chat, I think we're a couple of seconds behind, so we need to wait a bit. Can you say something again, Joseph?
Yeah. Can you hear me?
Yeah, now it's better. Okay, keep on going then. Sorry.
Okay, I'm not sure where I stopped. But yeah, your own type can be made a monad. You can just implement the members for
Yes.
it, and it works. The standard stuff is like coped with in the FSharpPlus library, and yeah, I think you are good to go. I don't like, even though a lot of stuff is monad, like there is not much like you need what's not implemented in the library. So I've actually never had something which is a monad and I created myself, or was in other library which did not know it's a monad and I needed to use it like that. So I hope, I think that's what the question was asking about. I just forgot what the NTL shortcut stands for.
Okay, now my voice just pitched gone. This happens with this mic from time to time. I don't know. I think it should be better now. Yeah, thanks for the explanation. So if the voice, my voice should be better now. It's not like this demon voice that sometimes happens. Oh, okay. So I'm already talking for 10 minutes in a deep voice. Okay, it should be better now, I hope. Cool. If this happens again, please tell me. I don't recognize this. It happens all the time when I'm doing my team meetups, meetings now, and I don't know what this is about. I have one more question, which is basically about my question about error reporting or error. So how are the type errors? Can you actually make sense of it? If you have any errors in there, or is this a problem, or is this? I can imagine if there is a lot of this SRTP resolver thing going on. Can you actually make sense of the error messages if you make something wrong?
So I agree that for beginners it will be super hard. It's very developer unfriendly if you are learning that stuff and you don't know where the error is.
Okay.
The error messages are not user friendly. So yeah, that same applies for lenses, and like all these inline and static resolve types. But after trying a bit, you come to a resolution that when it's wrong, the easiest way is to actually look at the code and think about it.
Mm-hmm.
And you will usually, when you are used to the stuff and you will get like a grasp of it, it will actually be easy. So I have no problems with that, and I write like every application I write with this stuff I've presented. So, and I have no problems with that. Like, but I remember that the beginnings were
Okay, yeah, I can
a bit
imagine.
struggling.
Yeah. Okay. Cool. All right, I'd say we are on there for 1 hour and 20 minutes. So I think you have one last part, which are the lenses, right?
Yeah.
Okay.
I hope we can make it.
Yeah, we will. We will see. So let me switch back to your screen, and we will keep on going with the lenses.
Okay. So the last part, lenses. Let's start with the motivation. What are they? It's actually a concept that I don't see a lot used. Monads are famous for being complicated, but lenses are not being famous at all. So let's correct it. So if you have a mutable world, usually an OOP one, and you have some data structure like a shopping list. The shopping list has items. The items have like an amount and the food stuff. So it's like a shopping list with 5 tomatoes and 1 kilo of potatoes and stuff like that. And you want to change it. Let's say you want to change all the items that are for the given food stuff to 1 kilo. This is what you do in the standard, let's say, C# code. And it's nicely readable. You just say, give me the shopping list, items where the food stuff is equal to some ID, and change their amount to 1 kilo. It's a pretty declarative in a way, but the problem with it, it's mutable, and we don't like that. So we will skip to like implementing in mutable way in F#, and what we get is a mess. Like, compare this code to this one. It's just not readable. even though it's immutable, which is like a really strong property, which might be even like worth the effort in the code, but this is just horrible. Here I create a function replace item, which will compare the foodstuff ID. Then it will create the new item with that amount. Otherwise, it will keep the item. Then I map the whole items, and then I create a shopping list with new items. So no, this is horrible. This is not as readable as it was, right? And we want to make that right, and that's what lenses do. So this is how it looks with lenses. And some of you may now be like, what is this? Again, maybe. What is this? So as with the monads and every concept, like in functional programming or any kind of programming, the first time you see it, it's scary. But then you look around, and then you fall in love. So here basically it does the same thing as the previous code, but in a much more declarative way. You can basically you can basically think of it that lenses it's a way how to work with nested data structures and how to create pointers to specific places or points among the data structures. So here I basically say how to construct the points. So this is like the set of all the amounts I'm gonna change, and I'm gonna compose it. I'll say just on the shopping click items, go to the items level, filter them by this function, and go to their amounts. The whole thing set to 1 kilo on this list, right? So now it's much more clearer, and now it's like the same code in a way as the OOP one, that it's declarative. It really you cannot really remove much of like English words to keep the meaning. So that's pretty nice. Let's see how it's actually implemented, and at the end we will show some more cases. So how you can think of a lens in the first place, what you can come up with is that basically lens is getter and setter. It's a combination of two functions, one which can get you the value and one which can set you the value. So for the get, the signature is that usually the types are denoted with S and A, where S is like the whole thing, and A is the small thing within that, the pointer where we are pointing. So the get one is a function where you define how from the S go to A, and the other one is if you give me an S and A, I'll give you a new S with that A in that place. So for a type which is ingredient, which is the one we've used previously, with the foodstuff ID and an amount, the get, like the S for us in this case is the ingredient, and the A is the amount. Then the get is from ingredient to kilos, and the implementation is very simple. And then the set is also very simple. It's just, it takes the ingredient, new kilos, and returns a new ingredient with implementation, like with the record with like the copy on update syntax. But it's not it. Lens, you can think of it this way, but lens is much more. Lens is basically just one function which can do both. The way how you can think of lens in more reality is that it's get and set, but also a transform. So the transform function is just a function from A to A, from the pointer to a new pointer. And then what lens, we will start with the lens without a functor. So for now, let's say this is lens, is a function which takes the transformation of the value, the whole thing, and returns the new whole thing. So what it really does is it takes from this, it will call the getter, right? Now we get to A. We will transform the A to the new one, and we will call the setter with the new A. Thus, we get S. So what it really is get, transform, and set. It's very similar, like if you load the data from database, you transform it, and you save it back. But since we are in like the advanced FP stuff, we will put something more to make it a bit more complicated. So we can really have just one function, this all. and we will gain, of course, more benefits with that. So one motivation to say upfront is, for example, in the example here, we actually have not modified just a single place. We modified multiple places, and that would not be possible easily with just the get, set, and transfer. Thus, that's the reason why we put the functor there. And now the functor is really just a building block for a lot of fun. So the way how you define a single length, we will define a length for amount. So just to answer first question which usually comes up, do I have to define all the lenses for all properties? Yes, you do. You need to define a length per property. You can maybe try to write some generator if you want. So for example, Haskell, of course, generates them out of the box, but we have to write them ourselves. But it saves so much code in the usages, it's worth the effort. Just write, and it's super easy to implement it. It's not rocket science. So let's implement first one. For the amount within the ingredient, we will put the kilograms for the A and the ingredient for the S. And then we say that for the transformation function, which is from kilograms to functor of kilograms, and the ingredient, we firstly right at the here, we retrieve the ingredient from the retrieve the amount from the ingredient and apply the transformation function from it. Now we would like to put it in the setter, but we cannot because we have a functor. What we can do with the functor? Well, map it. So we just call map with the setter. This is the setter function. And we get a functor of ingredient. And the length must be in line because it works for any functor. Yeah. So now we have our first length, and now we need to look at how to actually perform get, set, and transform over it. How to achieve it with those functors. It's a bit tricky. So the set length is pretty easy. We will use a functor which is called identity, and the identity functor means I don't want a functor. You really can literally read the code with the identity functor if the functor was not there. The identity functor is just is defined as identity of A. It just has the value. So what we do with this setL function, which takes the optic. Lenses are just one of the optics. The general word for them is optics, so we call also lens an optic. So for the optic, which is this part, and the value and the source, we really just make the transformation like that. We ignore the current value and we put there the new value. That's the transformation when you set thing, and we just run the whole length. So that's super easy. So the way how we dealt, we knew how to make the set without the functor. The transformation will just ignore the value and put there the one we want. But how to do that with functor? We just put the identity there and it's settled. More tricky one, and don't worry if you don't get it now, is how to implement view. Because we have the transformation function, we have the setter, but really we want just the get. So we need to somehow make sure that the transformation and the setter are not like executed. And what's even trickier is that this length at the end has the S type, the whole type, but the getter we want the thing inside, right? The A, not the S. So there is a thing called const functor, and const functor is called like that because it's basically constant. So what it does in the map, you can see it throws away the function. So when you do map, it will do nothing on it. And it has two types parameters, one of the constant, and the other one is basically arbitrary. It's whatever it is because we will never use it. That's how we'll trick the type system to like say that we basically have f of s here, but the f is const of a. So that's how we get to it. So basically within the getter, we make the constant holding our value, then the map is applied, which does nothing, and we get the const a of s, and then we just unwrap it with the run function. So this is more like technical stuff, how to get it running. But this is how get is implemented. But then we have more interesting stuff, and that's over function, and that's the transformation. What if you don't have the value, but you really have just a function how to adjust the value? So for example, increase the amount of the ingredient by 1. So you can really just say in the code, over amount, add 1 on this ingredient. Yeah, and it's also implemented with the identity functor, but we don't throw away the like input. We use the transformation function really here. So it's similar to set, but we use the transformation, and this is pretty nice. Now, what we can really try is to not use any function like set, get, or over, but use the length as it is, because length is really just a function. So then if we have a function called try decrease, which takes kilograms and returns option of kilograms, that cannot be basically below 0, then if you have this is basically the transformation function, right? The A is the kilograms, and the F is option. And then if you have the functor and you apply the transformation function, you will only be left with give me the source, and I will give you the F of S. So you give the ingredient, and the whole thing will return the ingredient option. So you can take a function which may fail or do whatever what you want, return some functor. I would say the primary usage would be that it can fail, so returns an optional result, and you can like uplift it to a function where the whole thing is in the option. So this is how you can use it without the actually some like get, set, or other helper functions. If you need to, this is also pretty handy. Now, what makes Lenses so great, what basically makes everything in functional programming so great, is composition of things. So how about we compose those lenses? And if you look at two lenses, it takes the transformation function as an output and returns this function as output. So this is an input, and this is the output of the function. The other lens has this as an input, the transformation function. This is the output. You can really see that the output of the first lens is the same thing as the input of the other lens. So lens composition is like just function composition. There is no really more to it. That's it. That's why we could have used this operator. We usually use it the other way around, so we can read it like a dot. So it's not like the path is from top to bottom, not from bottom to up, but you can also use it like the other way around. So then if you have the ingredient and you have the recipe where you have some main ingredient, let's say, and you define the length for the main ingredient the same way we did for an amount. So this is just a getter with F. It's pretty much boilerplate. You copy and paste it. Then we can create a function which sets the main ingredient's amount just by saying that we will compose it like this. We will say, for the recipe, take its main ingredient and go to its amount then. You compose those two lenses, and you compose it so that the pointer is directing to the amount, not to the ingredient. So this is really just, you can think of it as if you will have a dot here in object-oriented programming, you have a main ingredient, dot amount, dot blah, blah, blah. And you compose the lens, and with the lens you can do anything. You can set it, you can get it, you can use the raw usage with the functor there. So that's really great. That's one of the main reasons why the lens is just a single function. And this is just to demystify myself. I've been lying a bit. The true type of lens is actually this, because you have some examples like a tuple. If you have a lens which takes the first item of a tuple. This is also defined in the out of the box in the FSharpPlus library. You can change the type even, because if you have this tuple and you set the first item to be a string, then you change the type. So that's why we need to have different types here in the definition, because in this case, we also change the type, so we need to come with that. Yeah. Then we find out that functor is not enough, that if we would use applicative, we can do more. And the more is that we can actually point to multiple places. I'll show the example right away, because it's defined out of the box again in the FSharpPlus library. So what you can do, there's this function items, which will basically go down to the item level of some collection. So for a shopping list of items, we can compose it like this. We are now back into the original example. We can say that for the shopping list, go to its shopping list items. On that collection, go to the item level. So now here we are like looking at multiple items. Then filter it by some function, and then go to its amount. Right? So you really compose the whole path where you wanna go, and then you can do anything again about it. For example, here I said it. You can view it. You can do over again. So that's pretty neat. That's something. Now it's not just like we have started with something that we want to, let's say, do the same stuff as with the mutable code or mutable data structures. But now we have come past that. We can do even more, like the error handling and the composition and the going towards multiple points and stuff like that. So another example which did not fit precisely the screen but mostly did, which is defined in the workshop, is for example, let's say you have an account with some contact information. The contact information has addresses, and each address is a city. And you want to like migrate all old cities to some new city. Let's say a city gets renamed or something like that. This is again how we would implement it. You define the transform city function, and then you need to transform all the addresses and create all this like tree down the bottom. This is again in the workshop. This is an example. There are other examples in the workshop, so I highly encourage you to check out that repo. But with the lenses, we can do this. We can again just say, for the account, go to the contact info level, to its addresses, to its items, then filter it where the city is the old city, go to its city and set it to the new city. Right? So it really makes it super concise and nice. So what you really, and there are other use cases even, like you can do virtual properties, right? And nothing tells you that you have to write the lens the way you do, like just with the boilerplate copy and paste. You can do calculations there. So for example, if you have a kilogram, you can define gram lens, which will like convert out of the box the kilos to grams, and you can now look into the grams of weight super easily, and you can even set the grams of the weight, and you can transform the grams. You can do anything. You basically create a virtual property that you can play with. And this is just something I found on the internet. I don't really understand it, but this is also something you can do with lenses. But so where is the place for lenses? And that's your domain layer. Like we have basically throughout the talk, we have gone through all the layers. So in the domain layer, where we have just the model defined, you have the basic functions. That's where you will usually create new instances of your model. So that's where the lenses belong. Then you move to the, let's say, like a business layer or use case layer, where you need some database access and stuff like that. That's where you use the reader. That's where you do the result, or like as we spoke about the whole ZO monad. And then you move to the API layer, where you basically just need to parse like the language of the communication to the language of the type system, and that's where you use the applicative for. And that's how you basically how we can use all these concepts in your whole application, which is showcased within this repository and my other repositories. So here are some links you can use. So of course the FSharpPlus library, where you can export it and everything. Then there is, if you really want to go deeper, this is a great book from Bartosz Milewski on category theory. And of course, I include also some language reference on the static layers of type parameters because those are important. And as I said, I haven't said everything. When you will be trying this, you will have questions. So anytime you have a question, just direct message me or tweet me on Twitter under this nickname. Or the FSharpPlus library has some community around that, so you can ask Stack Overflow questions or go to the Slack channel. It's all written out on the library README page on GitHub. And yeah, just reach out for help, because I know that the beginnings can be struggling, but there is a lot of people willing to help. So I guess that's it. Thank you for withstanding the whole Monads with me and everything. Now I guess it's the time for questions on lenses and even some like overall ones.
Yeah, thank you. Last part was hard for me, but I really like the idea. I never worked with lenses in this sophisticated kind of way. Really cool. Definitely need to read more about it and think more about it. But I liked your last examples a lot. So let me see. Yeah, there was this one suggestion. So who will write a Myriad plugin for lenses? So Myriad is this metaprogramming library from Dave Thomas, 7#9, which would be pretty cool to have if you have like deep nested records or data structures that you can actually generate those lenses automatically for you, right?
Yeah, it's even speaking of that, like we have now the announcement of source generators in C#. Yes. So basically, you could even implement lenses in C# with source generators easily. But of course, in C# it's pretty unidiomatic to use immutable data structures a lot. So
yeah, definitely. So let me see. I think people were just basically talking about. So they were liking your framing for lenses and your introduction. I also like them a lot. And I don't know who said it. I think it was Chad who said it's basically differentiating or decoupling the type representation versus the type accessor part from each other, yeah. Which is nice because you might even be able to change the representation of your type a bit, I guess, without having to really change a lot of places in code, but to actually change the lens, if this makes any sense, I don't know. But I can imagine that this is actually possible then. So I think I think there are not so many more questions. It's like as Paul said again here. So as with so many things, more work is needed to surface the concept in an optimal phrasing. So I think a lot of people are not really used to or having problems with the representation or how this actually looks like then in code and how we can actually express those really nice patterns. And especially with lenses, I think we really try to solve a problem that is there definitely to access these immutable data structures and update them in a nice and concise way. And
like a good exercise I have for lenses is when I was implementing a mobile application and I was connecting this, of course, to some API, and I mocked the API to work somehow. That's a really good exercise for lenses because there you just want to like change the stuff in memory, like the fake environments and stuff like that. It's a really good exercise because you get to change the stuff a lot, and the only thing you're doing there. So it actually went from a point where I was to write the fake implementation, and when I discovered lenses, it was just a few lines of code. It made me like write it properly.
Yeah, really nice. So this was really good and really nice thing. So one thing for just for my own thing here, maybe for the last couple of people that are there, I mean, couple of almost 90 still, but we are talking for 2 hours now, so it's really cool. And I really enjoyed this, and the people, the chat was really active and had a good discussion. So some people were asking in the beginning if how we can actually support this, the conference or this channel or F-Sharp Online and the stuff I'm doing at the moment. So if you really want to support this stuff in a money-wise thing, I have set up for my own YouTube channel and all the stuff I'm doing there, the DevOwl, I have set up a Ko-fi thing where you can actually buy me a coffee or two if you want to do this. It's really nice because all the equipment for doing these streaming stuff is really expensive. So if you're interested in this, it would be nice, but I'm doing this anyway, so don't feel pressured in any way. So I really enjoyed this. I had a lot of fun. I learned a couple of things, definitely. And so if you have any questions, just ping me or ping him, ping the F-Sharp Online Twitter. We're still looking, we're always looking for speakers. We have a long list of speakers that are wanting to speak. So if you're one of them, I'm sorry, we can only do so much. And I'm not sure when the next meetup will be. I'm trying to make some before the conference, but for the conference, there is a lot of work to be done and to prepare and to talk to speakers and to prepare everything, which will be a couple of hours. So I'm not so sure about this. I'm trying to do it. But still, if you have any comments or if you have a really good idea or you want someone else to talk about a really cool topic about F-Sharp or anything related, just drop us a line, either Roman or me, the other Roman, and we can do this. So from here on, thanks a lot, Josef. I had a lot of fun and learned a lot, and it was really cool. So I hope to see you folks around, and have a good night, good morning, good day, wherever you are at the moment. Stay safe, stay healthy, and bye-bye.
Bye. Thank you for having me. It was a pleasure.
Yeah, thank you too. Bye.